Okay, so now what we're going to do is, first off, we're going to look at a new data set. So to give you a little context of the data that we're looking at now, what we have now is 199 different high school students from North Carolina reporting on a series of different responses to a number of questions. And so we're only going to focus on two of these, namely two categorical questions. And so what we're going to be investigating this time around is, instead of looking at differences in population means like we did in the last video, we're going to be looking at differences in population proportions this time around. So we're going to be looking at categorical data. Namely, the two variables that we're going to look at are school pressure. And so school pressure is looking at a measure of essentially students reporting whether or not they felt very little, some, none, or a lot of pressure from their schoolwork that they were required to do. And then the other variable that we're going to look at is planned education level. Now, planned education level is what students state as the highest level of education they plan on receiving after high school. And sometimes it is high school. So again, we can look at a graph, bar graph of this, and we can also look at this in terms of frequencies and relative frequencies. Now notice when I inputted these two things, I had a choice for our percents, so our relative frequencies, and it defaults to row. So let me spend a minute here to describe what that means. So when we look at these percentages here, so for example, if I'm looking at this middle cell on the top row, what that 4% means is that 4% of students that reported feeling a lot of pressure from their schoolwork responded that their planned highest level of education would be other. We don't really know what other is. So what we're looking at is our totals are our rows. So we're treating each of these as essentially our distinct populations that are our totals. And then we're looking at a proportion of that population's total that falls into each of the different planned educational levels. So when we look at these, we can see for the most part, people fall into a lot or some. And in terms of the planned education level, they fall predominantly into that graduate degree level, is where we're seeing most of ours. And so to do a comparison between our two different populations, what we're going to do is we're going to focus on these two populations. So first off, we're going to compare the a lot of school pressure population to the some school pressure population, and the specific proportion that we're going to look at is those in each of those populations that report planning to attain a graduate degree as their highest level. So if we look at it in terms of our sample here, what we're really comparing is this 88% of students that reported a lot of pressure from their schoolwork and plan to attain a graduate degree, compared to the 72% of students that reported some pressure from schoolwork and plan on attaining a graduate degree. And what the question is that we're really trying to answer here is the difference between these two proportions significant? So if we look at this as a direct difference, the difference between 88% and 72% is 16%. So what we want to do is see, well, is that 16% significant, or is it just a small difference and it could just happen by chance? And so again, just like in our previous investigations, what we're going to again go to investigate this issue is we're going to go to the idea of creating a sampling distribution from this, using essentially this sample as a population that we're going to then draw random samples from. So when we go to do this, first off, we're dealing with an original sample of 199 students. So this is significantly larger than the previous samples that we had looked at. What we're going to do this time when we draw our random samples is we're just going to go ahead and draw 100 students out of this large sample. And again, we'll do the 100 samples total because it's going to make it easier for us to look at finding an interval that's going to contain about 95% of those points. So again, we're going to make this fast because this is going to take a minute. And there it goes. So here we are. We're collecting our 100 samples in the middle. Each sample contains 100 different items over here on the far right side. And so this is going to take a minute because you're basically going to end up with 100 times 100 items, so 10,000 items, which is quite a large number to be drawing, even with the assistance of the computer. So what I'm going to do while that's still going is I'm going to start to talk about what we're trying to measure. So remember, we want to create a sample statistic here. And what we're looking at is the difference in sample proportions. Now, if you remember from when we did our first investigation into this, finding the sample proportion from a sample statistic was a little more drawn out than finding a sample mean. That's only increased when we're looking at this in terms of this bivariate categorical data here. And so I'm actually going to do this as in steps. So we're going to create two different attributes first. One that's going to look at the sample proportion of people that reported a lot of pressure, school pressure, and plan to get a graduate degree. Then in the separate attribute, we're going to look at the proportion of students that reported some school pressure and planning to attain a graduate degree. And then our last attribute, our third new one that we're going to add, is going to actually look at the difference between the two of those things to do this in steps. So I'm going to first start off by creating a new attribute in the sample. And this one is going to be our sample proportion for, and we're going to look at this in terms of a lot of pressure. So once I have that, now I have to edit my formula to input this. So remember before, we're dealing with a sum, because what we want to do is we want to count up how many of these things are in a particular category within this variable. But we're only looking at certain categories that we're trying to come up with. First off, we're looking into school pressure as our actual category that we're going to count from. And what we're trying to count from that is anything that's a lot. Now, we also have to look at basically the intersection between two variables, though. So I want to see not only students that reported a lot, but I also want to see students that reported attaining a graduate degree and a lot. And so what I have to do is then tell it this second component to it. So now I'm going to look at planned education level. And within that planned education level, what I want that to be equivalent to is a graduate degree. So now I have basically my numerator here. What I need though is I need to divide by my denominator. Now remember, what we're doing is we're treating the rows as the populations, or the totals in this case. So what I'm going to divide this by is actually the sum, and in this case the sum being the sum of the allots in this total. And so I'm going to again use my sum function, but this time I'm going to say, well, I'm going to sum it if I'm dealing with my school pressure being equivalent to a lot. And if I've done this all correctly, here are our sample proportions of students that reported a lot of school pressure and planned education level of graduate. Okay, step one. Step two. Now we need a sample proportion, but this time we're going to do it for sum. Now, this formula is pretty near the same as what we just did a minute ago. So rather than retyping this beautiful thing from start to finish, what I can do is I can actually copy it from the previous one, and I'm going to go ahead and paste it in here. And then what I'm tweaking this time around is that instead of my school pressure level being a lot, what I'm looking at is my school pressure level being sum. And so I just need to change my allots to sums. And again, if I did it correctly. Now we're looking at the proportion of each sample that reported some pressure from their schoolwork and also had the planned education level of a graduate degree. So what we want to know, though, again, is the difference between these two things. And so that's going to be my last attribute, is that's going to be the difference of the sample proportions. This one is going to be a nice, easy formula, because all I'm going to do is I'm going to take the two formulas I already calculated and I'm going to subtract them. So I'm going to take my sample proportion for a lot, and then I'm going to subtract from that my sample proportion for some, and what we're going to see now is the differences in those sample proportions. So here are these 100 differences. Just like before, though, we want to look at a graph of this and look at this distribution. So here's the graph of my distribution. So again, we can start to describe this just like we have previously in terms of what's the shape, center, and spread. Notice, and you should see a trend at this point, that pretty much every one of these sampling distributions we come up with is symmetric in terms of the shape. You should also notice that when we're looking at the center of these distributions, the center should be what the parameter is that we're estimating. So in this case, we're looking at the difference between the sample proportions. So if we go back to our original sample, that 88% and 72%, the difference between those is 16, or in the case of what we're looking at is 0.16. If we look at our mean, we're pretty close to that at 0.15. So the next thing we want to do is we want to come up with that interval again, right? So if we're looking at the center being about 0.15, so about 0.15, and we want to encase about 95%, so all but the tail 5 of these things, then we have to figure out, well, how far above and below this do we need to go to do that? So if I look at this in general, you know, I see 2 kind of straggler points up here and then 3 down there. So if I can do everything to basically exclude those 2, what I'm going to come up with is my confidence interval with that. So if I want to go up to, but not include these top 2, well, I'm going up to 0.34, we'll say. So if I need to go from 15 to 34, what we're talking about is a distance of 19. So if I go 19 above, I'd also have to go 19 below that. So if I go 19 below my 15, I'm down at -4, and -4 is going to be somewhere right around here, which is actually going to contain this point, but it's not going to contain these other 2. So in this case, what we'll do is we will exclude 4 points, and we'll do that by using a margin of error of 19 above and below the mean. So then, if we want to state this in terms of our interval and then answer our original question that we were looking at, our interval is going 19 below and above this point. So what we're saying is we're fairly confident that the difference in these 2 proportions is somewhere between about -4 and +34. Now, if you remember what we talked about when we were talking about the difference in the proportions, that value that we're looking for to be in that interval to show that there's no difference would be 0. And if we're going from a negative lower bound at -4 to a positive upper bound at +34, then what that means is that 0 is contained with that in that interval. Now, it's on the edge of that interval, so it's less likely than what we saw in our proportion example, but still there's likely a chance that we could see no difference between these. And so we don't really have evidence that there's a difference in the proportion of students that report a lot of pressure from school and some pressure from school that plan to attain graduate degrees. And now we've looked at a comparison or an estimate of a difference in population proportions.